Today is Wednesday, October 16th, 2013, and I'm speaking with Bob Bochman, president of Dexmet Corporation in Wallingford, Connecticut. Bob, your company produces lightning strike protection equipment for composite aircraft. Can you tell us a little bit about why composites need lightning strike protection?
Well, when I first started coming out with composites for aircraft, now 25 years ago, the whole purpose was to try to reduce the weight of an aircraft. One of the issues they found that replacing composites, although very strong, from the original aluminum design, because aircraft do get hit by lightning, when they got hit, they were shocked to find some serious damage done to the composite, so much so that it would blow a hole right through it. So, going back as far as the 1980s, they needed a solution, and we have been producing a very thin mesh material, variety of different alloys, and one of the aircraft manufacturers that was at the forefront of this needed a solution to it, and we put our mesh in that composite, hit it with the same 200,000 amp lightning strike, and there was virtually no damage at all. It was just surface damage basically to the paint, and we were well on our way. Little did we know back then it was going to take 25 years to really get this thing launched worldwide. What we started putting in these jets was a very fine mesh designed very unique for each aircraft, or for in fact each area of a plane. But basically it was a very fine expanded metal that was designed with unique features of thickness, weight, and conductivity, and needed a hole in it, an open area type product, so that the flow through of the composite film layer that they were laying on top of the strength part of the jet would give it the right adhesion, eliminate micro cracking, and a whole series of other problems. And we found our niche. We had the capability to produce these thin materials primarily for the battery industry, so it was a natural fit as we transitioned over from a power program to a lightning strike program.
It's an interesting history, Bob. What programs are you on, and which manufacturers' airplanes are you on today?
I think there's not many that we're not on, so when the program started with Embraer and Boeing years ago, Bombardier and Airbus rapidly caught up, as well as all of the other military type programs. So we do our development work with that team, and then from there it'll spread itself out into the composite manufacturers themselves, the pre-preggers, being the Cytex, Hexcels, Henkels, 3Ms, to name a few.
Oh, that's great. Where do you see the future of this product and growth as we move to more and more composite structures on airplanes with 787 and A350? Are you finding an increased demand for this product?
Well, I think we're just at the beginning of the whole cycle. Everybody is working really fast on developing these aircraft, but there's not that many of them that are up in the air flying. So the next generation is certainly going to be composites, and the price of fuel, cost of manufacturing, those are all driving factors. I mean, we're given numbers in the range of $15 million of fuel savings over the life of a jet by switching to a composite structure from a solid metal structure.
How about repairability? When a structure does get hit by lightning, there was minimal damage. Do you need to replace? Do you ever need to replace the mesh within the composites, or is that something that gets smoothed over with a repair kit and refinished?
I think one of the attractive features of using our material as the lightning strike scheme is that because all it does is where it takes the initial hit right at that point of impact in an area, no greater than a 12-inch diameter, it basically it gets disintegrated, but it's at the it uses itself so that the structure itself has no damage. And our material is not really part of the structure of an aircraft. It simply serves the function of being a lightning strike protection. And it's a sacrificial part of that whole scheme. We're told some of these repairs can be done literally overnight. So they're going to get better at doing it as more fly. I don't think many of them have been hit by lightning actually yet.
Yep. Well, that's great. What else does your company manufacture, and what other industries do you serve?
We go out there today and we say we can expand any metal as long as if you can bend it, we can expand it. That's expanded itself over into the polymer range. We're very good at expanding fluoropolymers. So we're serving markets ranging from power, and within that power industry, it's advanced batteries, fuel cells, solar panels. On the filter, we do a lot of filters, and primarily it's our ability to expand very thin plastics. And we're in some unique automotive applications as well. We really serve a pretty diverse customer base and product base.
It sounds like that you've got a pretty good technological base there. How thin can some of these materials that you expand get?
We'll expand down to 001 in production, and we've done samples for customers trying to develop new products that go down all the way to 005 inches. And on the other end of it, we have width capabilities up to 48 inch, or actually even we do a product that's 49.5 inch today.
So we could look at it. Thanks for speaking with us today, Bob. We really appreciate it.